Thank you, Corinne. So this takes us to the first session. So Edgardo Greising is the chair of the first session. Edgardo is the head of the Knowledge Management Solutions Unit at the Department of Statistics of the International Labour Organization. He is a member of the SDMX Secretariat and of the Supporting Standards Group of the HLG MOS UNECE. Sorry, that's a bit of a mouthful. So yeah, please, Edgardo, if you could come up. Thanks.
Okay, so thank you, David, for the introduction. And it's a great pleasure to be here, sharing this session. It's an honor, and I really thanks the organizers for our confidence.
Yes, you should activate the microphone.
Okay, sorry. I was saying that it's a pleasure to be here. It's an honor as well to have been invited to chair this first session. So my gratitude to the organizers of Cosmos. And because time is short, let's start with the first of 4 presentations we're going to have in this first session. And the first presentation will be by György Gyomai, György, and he will be talking about modeling and harmonization of units of measures. György is an economist who, according to him, with time became a statistician, and then he has become an IT person. So it's an interesting mixture of knowledge that we have in György. Over the last couple of years, he assisted 100 data producers to remodel and harmonize their structured metadata with a view to populate OECD's new SDMX-based dissemination data warehouse. And in this presentation, he will be talking us about a preliminary study made by a task team of the SDMX Statistical Working Group, established with the aim of issuing recommendations of best practices in modeling units of measure, considering different contexts. So, György, please, the floor is yours.
Thank you, Edgardo. Hi, everyone. I will be speaking on behalf of the small team who has been working on this issue as part of a task force triggered by the SDMX SWG. So you see my co-authors for the paper that was submitted and my partners in the exercise of trying to boil down all the learnings and experiences that we have had in the recent years in working with data warehouses, multidimensional modeling, and specifically trying to represent units of measures in these contexts. So as you can see from my slide, the main initiator for this work is the task group belonging to the Statistical Working Group of SDMX. So our work is mostly inspired by everything that SDMX brings with it. So again, it's multidimensionality or multidimensional modeling, and working mostly with socioeconomic aggregate data. But the work wasn't just launched from nowhere. It was preceded by several hundreds and thousands of hours of discussions that we have had in global data structuring exercises in national accounts, labor statistics, and SDGs, and many more that are not on the list. So the main reason we felt that something as trivial as the allocation of units of measure needs a task group and some work is that when looking at the actual practice of units of measure allocations in all our data warehouses, there is a lot of mess, or if you don't want to call it a mess, there is a lot of conflicting conventions that guide the ways users work with numbers, and then how they append numbers with the unit of measures. And we believe that good unit of measure allocation, it's very helpful for the consumer of the data to get a good understanding, an immediate understanding of what is the scope in which they can use the data or where it comes from. And this leads me already into the rationale of the work that we have done. We think and we strongly believe that in economic and social statistics, we can have the same level of precision and accuracy in terms of working with units of measure as it's common with other fields of, or more hardcore fields of science. And perhaps we cannot transfer everything as is from the SI system, but we can reinterpret and keep the most of its principles. And specifically, one principle that we believe it's very core to our work and should be very core to how we work with units of measure is the reliance on dimensional analysis when we derive units of measures from some base axiomatic set of units of measures, or we build up a larger system from a few initial cases. So, as you will see, in our work on trying to apply scientific best practices to units of measures, we have had two things that were special compared to how in scientific fields units of measures are applied. And one of them is that there are specificities to the domain, to socioeconomic statistics, and the other is the specificities of not working in a very simple tripartite setup where you have the measured quantity and then a number associated with it, or the measurement value and the unit of measure. But quite often we have a lot of structure around the numbers. So, and that's what we try to think systematically through and put into the or back up the guidelines that we shortly will publish and put forward for public consultation. So let's see what is special about the socioeconomic statistics aspect. So compared to the SI system, we have a trivial new dimension, which is economic value. That's something that doesn't appear in the SI system. And it's a quite straightforward thing. So we will have currencies mostly to capture economic value. But as you will see from my next slide, in conjunction with the multi-dimensionality of the modeling, it has some complexities that are not necessarily so trivially visible in the SI system. And then the other thing that comes through from socioeconomic statistics is how we would relate, or how we should relate to the counting dimension, or better said, counting dimensions that are prevalent in the socioeconomic field. In science, there is only one so-called dimension or extent, which is being modeled, and that's the amount of substance. And usually there is a trivial way to make connections of the amount of substance to the mass of the objects. And even when we talk about particles, atoms, protons, and molecules, these are all kind of proxies for mass. However, in economic and social statistics, we making that leap of thought and having the correlation between a person or an inhabitant or I don't know, something that we count, registrations or companies, establishments, it's not so trivial. So it's quite clear that in the domains where we work, there is probably a need for many more dimensions, or at least units of measure for objects that we count and sets that we describe by counting. And so here we have, if you look in more detail into the paper that is supporting the presentation, you will see we have a quite detailed elaboration on how we recommend using or working with counted quantities. But the gist of it is that the main point to associate a unit of measure with a set, I only have 2 minutes left, right? Okay. So I will speed up. So the main point to associate units of measure with counted quantity is to describe the set as the measured quantity, add the number, and then identify the ideal element of the set as the unit of measure. And we see it already in STEM that the mole and all the practices that are used there to just call everything an entity that is counted, in most cases is insufficient. And there has to be a more specific way of describing the counted quantities like particles, or instead of particles, atoms, protons, or molecules, depending on the context. And that's what we recommend. Analyze the comparability scope and computation use that you want to have with your data, and use persons, inhabitants, or establishments as units of measure whenever necessary. I'm happy to elaborate later on if you have questions around this and I couldn't clarify everything. Let me just very briefly go into the data warehousing aspect. So the data warehousing aspect is interesting because, as I said, we describe the data or the context of the data in multiple dimensions. And if we look at, in a very blunt way, to the data that we collect, initially is just a bunch of data, and it's just numbers. And we have to decorate these numbers with dimensions and attributes to make it intelligible and interpretable by the end users. And in doing so, quite often we have not a single unique way to do. We have choices to make. And the example that you see here first is one of the biggest choices that you can make when you create ratios of commensurable quantities. We recommend the second one. Again, I don't have too much time to go into the details on how we propose that, but just remember it's a practice that we labeled change of measure perspective rather than a change of unit of measure perspective rather than using the ratios as we do it in non-structured data analytical context. And the other one is probably less trivial, but it points back to my point earlier on measuring economic value. Quite often it makes sense to add structure to the units of measure, so that not just capture them as one long text, but organize them in multiple atomic concepts that make the structuring of the data easier. I think I should finish here, but I leave the going forward slide for a while. We are planning to have consultations on the paper that we put forward, and get as much consensus around it as possible. Thank you.
Thank you, György. While we switch to our next speaker, I will invite all of you to post 2 questions that we will answer at the end, but just to use this time and to avoid you forgetting what you were thinking of asking György. So, does anybody have any question? I know it's the first session, you might be shy, but help us. Okay, great. Thank you, Barbara.
Yes, so you were
microphone.
Okay, thank you. You were speaking about atomic concepts for better describing the units if they are complex. So do you agree that we need also for those semantic concepts, not just decompose them, but also have referenceable atomic parts based on ontological concepts?
Okay. We leave it open. Don't forget, György. Any other question? Yes, Marco. No. Quickly.
Hey, György, just a question on the issue that you are also raising in the paper about should units of measure be modeled as dimensions or as attributes, where you have many good content-wise recommendations, but there's also an interaction between say content and the technicalities of how you want to handle with data. Very often in our use, we tend to cut the cube in thin slices, for which a unit of measure at the end becomes an attribute rather than a dimension. You can identify precisely the data without specifying the unit of measure as a dimension, or maybe you have only one unit of measure, and then at that time you declare it rather as an attribute rather than a dimension. So I don't know if in your recommendations there's also space for this issue of considering the use of how people tend to design the data. And in this case, I see also an interaction. You mentioned the SWG several times, but there is maybe an interaction between statistical and technical working group. We can discuss it at length. This is just to anticipate one issue.
Thank you, Marco. So now let's go to our second speaker, that is another George. George Alter will be talking to us about extending the PROV model to data transformation scripts. So George is a research professor emeritus in the Institute for Social Research at the University of Michigan. His research integrates theory and methods from demography, economics, and family history with historical sources to understand demographic behaviors in the past. From 2007 to 2016, he was director of the Inter-University Consortium for Political and Social Research, the world's largest archive of social science data. He has been active in international efforts to promote research, transparency, data sharing, and secure access to confidential research data, and he has worked on new metadata standards that improve the reusability and interoperability of research data. His current project aims to automate the capture of metadata from statistical analysis software, measure maternal mortality in England in the 18th century, and to create a fair vocabulary of terms used in population research. Today's presentation is about the structural data transformation history, or SDTH, which extends the PROV model to allow searching and querying data management scripts used for statistical data. SDTH is expressed in Resource Description Framework, RDF, and can be queried with tools like Sparkle. George will illustrate the use of SDTH with a query that answers questions like, what variables were affected by the variable X? So, George, the floor is yours. You have 10 minutes.
Oh, thank you, Edgardo. You already gave the structure of the whole talk, so thank you very much. SDTH is an extension of W3C PROV that was motivated by the need to answer four questions about scripts and programs that are used to transform data. And these are questions of the form, we have this variable, this outcome variable. What variables went into constructing that variable? Or we started with this variable, what outcome variables were affected by that? So how do we ask those questions, answer those questions? And we chose to do this as an extension to the PROV language, which is expressed in RDF and can be queried. But we needed to extend PROV because for the following reasons. So PROV is actually a very simple and abstract set of language. And it's based on two things, activities and entities. Entities are things, activities are sometimes are things that change entities. And PROV really focuses on process. It describes things in terms of inputs and outputs. So, you have one entity that goes in and there's a process and another entity comes out. But PROV has limitations for what we want, the questions we want to answer. First of all, entities don't change. Activities create new entities, and that limitation that entities don't change is very important, as you'll see. Secondly, PROV doesn't have concepts within it to describe data sets. There's no concept corresponding to a data frame or a data matrix. There's no way to represent a variable within a data structure. So what we've done is created SDTH to add these things to PROV. The key to understanding what SDTH does is in understanding the difference between a variable that you refer to by a name in a script or a program and what we call a variable instance. Variables that you use in programming in Python or R or SPSS or whatever are not the same as PROV entities because variables are by their nature mutable. Variables is sort of a container. It has something in it, but you can change what you put in there over the course of the program. That doesn't work in PROV. What we had to talk about are variable instances, which are constant in time. So a variable instance is a specific state of a data structure. It is a set of values, a specific set of values that a variable may have at a given time. And if those values, if you put something else into the container, you get a new variable instance. As an example, here's a two-line program. You have a variable called var_x. You set it equal to 10, and then you multiply it by 2, and you get a new value for var_x. You've got one variable name, but over in this two-line program, there are two variable instances because you started with 10 and then you got 20. Well, SDTH is expressed in RDF, which means that it's expressed in terms of a subject and object linked by a predicate. Those predicates are sometimes activities and sometimes attributes. SDTH is actually very simple. We have really only 5 entities. We've got programs. Within a program, there are program steps, and then we've got 3 data objects, a file instance, a data frame instance, a variable instance. Those things can be linked to other things. Each of the data instances has a name which corresponds to the name that's used in the source code. And instances can be derived from other instances, or they can be elaborated from other instances. Derived means that you've changed the value. Elaborated actually means you haven't changed the value, but you changed something else, like the data type. If you change a string into a numeric value, that's, from our point of view, an elaboration, and it's a different data variable instance. So here's the simple program that Edgardo referred to, and what this does is it creates a new variable from an existing variable, and then it creates a third variable, which by taking the second variable and classifying it into categories. So we've got three variables. The outcome is what I'm calling HH category. It's household category or something. So it's common to show RDF in the form of a graph where you see the entities linked together. So here's a graph of part of the SDTH for this command. There are here 5 entities. There are 2 program steps, and then there are 3 variable instances, which I just described. Each of the program steps can be linked to the source code that it came from. Each of the variable instances is linked to a name. So that name is what appears in the script or program code. And program steps can use an existing variable instance, and they can assign a new variable instance. So what happens is we start out with the PP household size, and then we get the household size, because the first step reads that and writes the new one. Derived from is a way that we can see the lineage of a variable. So in this case, we've got 3 variable names. Here there are only 3 variable instances, and we can see how they were linked together, which they were derived from. And that allows us to write queries in the Sparkle language that look like this, where what we're doing is we're searching for all of the antecedents of the final variable HH category. And what we find is not only the household size variable, which is the one that it was created from, but the antecedent of that, the PP household size, which is what household size was constructed from. And what I also want you to notice here is that although the Sparkle is working on the RDF, it's working on the variable instances, because the variable instances are all linked to variable names, the output is in terms of variable names, not in terms of instances. I just want to mention that there is another language that came out of our group that we call Structured Data Transformation Language. It does different things than SDTH is. I'm happy to talk about the relationship between the two of them if you have questions about it. So the final thing is that SDTH extends PROV so we can answer the 4 questions that we posed at the beginning. And to do that, you have to change the way you think about things away from variables and variable names to variable instances. We are currently working on a formal description of SDTH, which we plan to propose to the DDI Alliance to adopt into the DDI suite of standards. And you'll find some links to publications and about SDTL in our project. And here are our partners. Thank you.
Thank you, George. And same mechanic while Arofan, you go next.
Okay.
Yeah. So while we switch the presentation, a couple of questions for George about SDTH. Yes.
So, what's the one? Right. That's the one, yes.
Hi, George. I've just got one about versioning, because the graphs that you were showing there were at the kind of variable instance layer, but I saw something about data frame instances and file instances. If you make a change to a variable that spawns another variable instance, is there anything opinionated in there that says how that kind of propagates up the hierarchy of digital objects?
Don't answer now. We'll have the Q&A session at the end.
One word?
One word.
Yes.
That'll do.
Now, another question, because this expired.
I think I have one question for you. The work is very interesting here. I think that to be very useful, you have to have a very strong implementation for building the graph that you described in SDTH. And I was thinking, would you go to something like parse the AST of all the programs, all the languages that you want to support in order to build SDTH graphs? The abstract syntax tree of the program itself. Thank you.
Okay, thank you very much. Any other quick question? If no, then we're going to switch to the third presentation today, that will be Smart Metadata for Data Exchange, DDI-CDI and Fair Implementation. That will be presented to us by Arofan Gregory, who works as a metadata standards expert for CODATA and has been heavily involved in the development and implementation of standards like DDI, SDMX, and GESIM. His current focus is on the DDI cross-domain integration, DDI-CDI, standard, and the World Fair Cross-Domain Interoperability Framework, CDIF. Today, Arofan will tell us about DDI-CDI, that is a new specification being developed by the DDI Alliance. It is aimed at cross-domain exchange of data and metadata, and it's central to fair implementations in the cross-domain space. Arofan will describe the features of the DDI-CDI specification and will explain us why it is uniquely suited for use in cross-domain fair implementation, for describing the conceptual, logical, and physical structures of data and metadata intended for exchange. Arofan, the floor is yours.
Thank you, Edgardo. You make it sound very official. Actually, it's a shameless plug for what we've been doing. I'm giving this presentation as the chair of the DDI-CDI working group, and there's a number of us here in the room. And we have an announcement to make, which is that on Monday, after 4 years of very hard work, we took what we'd been doing and we transferred it to the technical committee in DDI for final sort of review and approval, which is a big deal. I mean, I hope it was worth the wait. But if you want to know who to talk to about it, come talk to me and I'll point you at the guilty individuals here. But there are a number of us here at the conference. And I want to talk about not everything that DDI-CDI does, but about how it addresses a particular use case here. I'm going to call this the FAIR challenge. And I don't think this is specific to FAIR, in fact, but it's kind of how I think about it, which is that the point of FAIR is to make things discoverable and reusable. So there's this idea that I should be able to go out in the world and get data of any kind from anywhere. And it's easy to find and it's easy to use. And that's a big ask, right? And it's something that, yes, is important in research data and FAIR in the way we typically think about it, but also important for anyone who's producing and disseminating data. So I think there's a policy aspect to this as well. But when you think about that problem, it emphasizes the need for very granular, very rich metadata. And that metadata has to be in a standard format. And FAIR is sort of defining that at a level where automation becomes possible. So the richness is sufficient to support automation because of the challenges of scale in this problem. Now, in the official statistics world, you have a bunch of organizations whose primary goal is the production of data. That's the mission. In the research world, the data is secondary because the goal is research, right? And so you have a lot of organizations that, yes, care a lot about data and work with data in intelligent ways, but who have that additional step of having to produce the findings. And so if I had to make a judgment call here, I would say that the industrial strength approach to data production tends to be more on the official statistics side than in the research side. Now, that's a horrible generalization, I'm aware. And we have great examples of sort of industrial data management and production in research. But what it does do is it really emphasizes the need in a fair scenario to lower the cost for data disseminators to obtain the maximum benefit, that ideal fair scenario, for the users. And that's what I want to talk about here, is how do we minimize costs and optimize usability? Fair isn't typically thought about as an aspect of data quality, but I think it is, especially for official statistics. In official statistics, people talk a lot about consistency. You look at quality reporting frameworks, and they tend to be a lot of information about the data being the same and comparable because it's the same. But what about how easy it is to use? And that's an aspect of quality that I think official statistics organizations can take from FAIR and really leverage if they want to. And these are the kinds of things I want to talk about and how DDI-CDI fits into this challenge, because I think it's a very big one. The basic approach that DDI-CDI has is to say, well, a disseminator knows what they know about their data. Their own systems manage it with certain metadata, and they can describe it in certain ways. And they produce formats and describe those formats with potentially rich metadata. But the users may have very different requirements. And the point of DDI-CDI is that it becomes an additional layer, a common language, if you will, that sits between standards or domain infrastructure formats and sort of logical arrangements of data, and allows you to take what the disseminator has given you, take the DDI-CDI metadata, and know enough to rip it apart and recompose it into what you need without losing the meaning of the data, okay? This is a little crazy, but you're basically leveraging a very formal, very specific metadata model to recompose data into what you need as a user. So you're offloading the burden not from the disseminator, who doesn't know the user's requirements necessarily, and handing it to the user who does know their own requirements. And it basically looks like this. You take the data, you rip it apart into things that are aligned around the variables and the datums in the data set that correspond to those variables, and then you have enough metadata to know how to reassign the roles to those components and make it into what you want. And this is a basic idea behind DDI-CDI. I know I'm sort of hitting you with a lot of stuff here, and I'm happy to talk more about this, but the truth is that these kinds of transformations begin to lower the barriers and increase the usability of data without increasing the burden on the disseminator. And that's the goal. At the core of that is how we describe and understand variables. And I want to take a look back, I want to dial back 20 years and think about how we understood and described variables 20 years ago. I've been involved with DDI for a long time, and in DDI codebook, which is still in common use, variables are non-reusable. They are descriptions of fields within data sets in the context of a data set, and that's where they live. You can't do anything with that. ISO 179 said, we have actual data elements, and those things can be maintained in registries and reused. You had a sort of two-tier system. You could have variables in data sets, and they could be implementations of these data elements so that you might be able to identify that two variables in different data sets were comparable. But that was forward-looking at the time. 10 years later, we get to the place where we have things like GSIM and DDI lifecycle. And we have this idea that there's a three-tier system. Yes, I have my instance variables at the bottom, which exist in the context of a data set. I have the represented variable, which is the reusable form of the same thing. And then I have a conceptual variable, which says, even though the representation might have changed because of a change in classification, because of something else, I still can compare the variables with a transformation or a crosswalk. And so you get a richer set of metadata for understanding the comparability of data. And that's good for management, it's good for use, and this was a huge step forward. Okay, now we've been playing in that world for 10 years now, and you'll notice that the word in the title of this slide is not revolution, it's evolution. Because DDI-CDI is not revolutionary. What it is, fundamentally, is an implementation of that GSIM model, that model that came out of DDI lifecycle, but it's an optimization of it for the kind of use case that I'm talking about. On the right here, you see that we have concepts, and the concepts can be specialized for use to define variables. And those things can be assigned representations, and that becomes our represented variable, and those represented variables get used in data sets, okay, as instance variables. That is the variable cascade, it's called. And what we've done in DDI-CDI is modeled that as an inheritance chain, so that a conceptual variable is a concept, but it's been specialized. It's being used as a variable. And when you add a representation to it, that's a further specialization that makes it reusable. But you know that two uses of the same represented variable are directly comparable because they're represented the same way. In the instance variable, we further specialize it by adding things that are dependent on the context. So things like categories, statistics, and all the information about the use of that variable in situ that don't exist at the reusable level. What we're really doing with this model, and it's a formal UML model that explains these, lays these relationships out, is saying that it can be treated polymorphically. If I have an instance variable, I have a represented variable, I have a conceptual variable, I have a concept. And that instance variable is all of those things simultaneously. Okay, I hope I'm not blowing anybody's mind here. And I know that some people will disagree with me because I've argued with them about this. But the benefit of this in that fair scenario is the data disseminator can describe their instance variables as they understand them. And the recipient of that data can expand that metadata into the complete cascade. Speaking of blowing up, with at least minimum valid instances of all of the classes further up the inheritance chain. So that if you give me an instance variable, I know your conceptual variable, or at least have a minimum version of it. This becomes really useful when you're ripping things apart at the variable level and recombining them in combination. When I have data coming from different sources, I have good descriptions of the variables, and I want to try to process those things programmatically. It gets better, though, because we have another set of very traditional metadata fields: populations, universes, unit types. These are things which are typically described as text in our metadata today. We have in CDI a parallel cascade, so that a value in a data set is about a particular unit. So I have the education level of a student in Belgium in 1973, right? And that student is a member of a population of all the students in Belgium in the 1970s. And the instance variable can be applied to each member of that population, right? This is traditional stuff. I'm nearly there. You get rid of the temporal and geographical classification. I have a universe, and so on. This stuff is really about describing the subject of the data, what it's about, rather than describing the data itself. But it relates directly to our description of the data. And there's a similar parallel chain that becomes more specialized. Why does this matter? Because RDF gives us very good tools for surfacing the polymorphic relationships and operating on them with things like Sparkle, which makes this directly usable without specialized OO technology. And the textual descriptions of the things in our unit cascade become really rich fodder for, I hate to say this, large language models. The combination of structured metadata and LLMs is a new frontier, but it's one that has a lot of promise. And because these things are related to each other, this gives us a really good set of tools for doing the kind of recombination that is, at the end of the day, what we're trying to do to meet that fair challenge. So I think DDI-CDI is a real step forward in how we model variables. I think it's the best variable model out there. Shameless plug. But I really think that this is a real step forward on the basis of what was initially found in Lifecycle and GSIM. So that's what I had to say.
Thank you, Arofan. Well, before our last presentation, Barbara, if you want to take your decision, 2 questions for Arofan about DDI-CDI. I'm sure you should have a lot. Yeah, Olaf.
Test. Yeah. Yeah, thanks. I heard about the 2 communities. So the production lines of the statistical offices, the statistical world, versus the scientific world, working with data, but the main goal is research. I heard you saying this a few years ago, and we talked about it, and now again. So my question is, did you see any change on the 2 5 years ago and now, and maybe 5 years after?
Thank you, love. Any other question for Arofan? No? Okay, think about it. Oh, yeah, Chris, please.
I can ask maybe a dumb question.
In the variable cascade, so compared to GSIM, you've got the extra level. You separate concept from conceptual variable. What extra benefit do you get from doing that? Just for my understanding. Thanks.
Okay, thank you, Chris. And now we are going to enter the last presentation of today. As you note, we did a small change in the original program because Barbara has some problems to reach us, but she was right on time. So the last presentation will be about IADOPT, a systematic way to represent variables. This will be presented by Barbara Magagna. Barbara is a Fair Development and Fellowship Coordinator at GoFair Foundation with a background in landscape ecology, GIS, and semantics. She's a trainer of the 3-point verification framework, for which she developed core components. Within European projects, she helps to fair assess data and services and to develop semantic frameworks like IADOPT. IADOPT is an interoperability framework for representing variables or observable properties in a machine-interpretable way. Barbara will tell us about applications of IADOPT to common problems in sharing social science data, data discovery, data integration, and the development of terminologies, offering a way to structure the information in a variable representation to make it machine actionable. So, Barbara, the floor is yours.
Thank you very much. So I'm happy to present a work I did together with George, Frank, and Flavio, and Stephen, because I was invited at the DDI-CDI meeting in autumn last year. And yeah, we looked into the applicability of the IADOPT framework in social science. And actually, somehow it happened that the first slide is now hidden, and it's about fair challenge. And Arofan has already introduced the problem. So we have to make metadata fair. So we need metadata to explain our data, but we have also to make this metadata fair. So findable, accessible, interoperable, and reusable. And actually, this is really a challenge because it's not easy. And lots of what we are observing, we can call them variables or observable properties in the social science, can be very blurry or very difficult to describe. And often there is no logical way how to address this properly. And yes, IADOPT is a systematic way how to represent this. And actually, comparing to the second presentation, where we also talked about variables, but in the programming language, I think it's a bit of difference what I address here. It's actually what we observe or what we want to describe in our research, in this case, in the social research. This IADOPT framework has been developed in the environmental science, actually, because that's also my background. So we really talk about observable properties. So what we can observe, we can describe with our research. Yes, and it is conceptualized as a semantic broker because we think that we provide standardized descriptions for variables supporting interoperability between existing terminologies by enabling also fair mappings between variable descriptions across terminologies. And this doesn't require any change to existing structures, but we add rich, human-readable and machine-read actionable descriptions with qualified references to existing semantic artifacts or terminologies. Actually, yes, by doing so, we can make these reusable, the variables reusable. Arofan has said that actually that's really hard. It was hard 20 years ago, I think, if I interpret this correctly. But now we can actually reuse some parts or components of these in other research descriptions. So let us start with a property that we want to describe. We always need a context to understand how to place this property, or how to understand this property. And this is the I-adopt variable concept in this case. So I-adopt variable consists of a property, and you have to add additional description components to make this variable more understandable for others. And so we developed a lightweight ontology called I-adopt ontology at the Research Data Alliance in a working group. And this I-adopt ontology is part of a framework that includes also recommendations that are now endorsed by the RDA. And I try to explain this now a little bit more in detail. So an I-adopt variable has actually a property, and it has an object of interest, and it might have a matrix and a context object. And the property is actually, and we can also read it a bit differently, and each of these components are entities, right? There's a property, and then we have entities that complement this description. And it can also be read like this, that it has all these components, a property, an object of interest, a matrix, and a context object. But the property must be really inherent of the object of interest that we are considering. And we need for a description at least one property of one object of interest. And in addition, we can have a matrix, but only one matrix, and multiple context objects. And in addition, this variable can also include constraints. And these constraints can constrain each of the entities, but not the property. I will then come with examples to make this more concrete, but the recommendations include that description should be human and machine readable, so humans need to understand it, but also machines need to understand this. And they should be as explicit as possible and include all the sufficient components to understand the variable and make them comparable. They should use semantic artifacts, so also called terminologies, that are compatible with linked data. And the I-adopt ontology provides a systemic way, a logic how to decompose these descriptions. And therefore, either you use a fair terminology that aligns with I-adopt, and you can just choose from there, or if there's something missing, you can create it on the fly based on this I-adopt framework. And here's some examples. For example, we want to know the date of the last PCR test. How would you decompose this? So the date of the last PCR test performed by a certified laboratory would be the I-adopt framework. So it's a composed description, a long sentence about what we are doing. Yes, but this is really hard to compare with other research if we are not starting to decompose what we are doing here. So the object of interest in this case is the COVID-19 PCR test. It's not a person, because we are looking at the date of that COVID-19 PCR test. And that's absolutely, you can break down each of the variables like that. You can find out, oh, I'm looking at a specific characteristic of my object of interest. So the constraint that I can apply, so I'm looking for the last, so the most recent one, is applied to the object of interest, and also that it is performed by a certified laboratory is a constraint on the object of interest. Another example is a number of nights in a 3-star hotel near the seashore. Actually, I see it's still the old version, but it doesn't matter. You have to decompose this also in in different parts and atomic parts where the property is a number, so it's a count, yeah? It's a count of, and what now is the object of interest? It's the guest nights. So we count the nights, yeah? And where are they? So where are they placed? In a hotel, and here it's wrong, so it should not be, the entity should not be 3-star hotel, it should be just hotel, and 3-star is a constraint. And near the seashore is another constraint, and both on the hotel, which is the matrix in this case. It's not the object of interest. And so there is a logic that you always can apply. We think it will always be possible to apply this logic. Let's look into 3 questions that actually two of them can be decomposed and represented in the same way. So the first question is, in the past 30 days, did you ever feel nervous? In the past 30 days, how often did you feel nervous? And how many times did you have feelings of nervousness in the last month? So actually 2 of these are similar, the same, yeah. And so the Q1 and Q2 and Q3 can be represented in the same way, because we are asking about how many times, about the frequency, whereas the first one is about the occurrence of this feeling. So the property is the occurrence here, in this first question. In the second and in the third, it's about the frequency per month, right? And it's important to understand exactly the nature of it. What I also wanted to say that the units are not really part of the description of the variable, because for me, a variable can be expressed sometimes in different units. So it's part of the whole description of the research, but not part of the variable itself. And to be able, last sentence, to be able to do this really to provide this framework to researchers to describe what they are doing, we need services, and we are building this service. We are developing an IADOPT service based on named entity recognition, and we will also look into large language models to support the training of the model on pre-modeled IADOPT variables in a large scale, and then which will then result into the decomposition in atomic parts and the arrangements in the different roles of the IADOPT, and attributions or reusing of existing semantic artifacts, concepts. So I hope this is a good contribution also to the social science to make your metadata fair.
Thank you very much, Barbara. Another couple of questions now for Barbara, and then we will have 10 minutes for answering the previous questions as well. So, yeah. Oh, sorry.
Thanks a lot for the presentation. I just wondered if you could say something about the Has matrix property. I'm just wondering what that is. Thank you.
Thank you, David. György, so OECD is very active in this topic.
Yeah, I was wondering about the property and constraint distinction in almost all cases where you presented the constraints. I kind of had this idea of imagining a property and then on the top of that property a constraint rather than directly constraining the entity. But I don't know whether you had that kind of deliberation or it's something that I misread in your slides.
Okay, so let's start with answering these questions. You okay? Yeah. So okay. Just to shuffle the order. So the first question was by David about elaborating a bit about the Has matrix property.
Yeah, so the Has matrix actually, as I said before, the initial science, we started to investigate where we can apply something like that. It's environmental, it's ecosystem research, and metrics was more the physical metrics, yeah, where you observe something. For example, a chemical substance in water, yeah, it's a physical environment. Now, trying to adapt this also in other research areas like social sciences, we have to extend this concept and say, well, where is it placed, right? So it's in a hotel in this case. It's giving the context, how do you say, the spatial context in this case. And then the other one...
Let's go one by one so
okay.
that everybody has opportunity. So, György, you had a question from Barbara regarding atomic concepts for better describing the unit. So...
Yes, and with the semantic angle, if I remember correctly. Yeah. So, I think that already the SDMX artifacts that we work with have some natural semantic meaning, the way they are structured in concept schemes and concepts. And if we follow the design guidelines, then the homogeneity of the elements inside a code list and then representing logically connected concepts give some semantics. But what we have observed is that probably a generic data warehouse, no matter how harmonized and how nicely it was modeled and built, would benefit for an additional layer of where semantic richness is added to the different concepts and made explicit. Some things that we as designers were thinking when we analyzed the data model and split them into different dimensions and attributes could be made explicit with other standards that could introduce that semantic richness. And it would work best at the discoverability layer on the top of a data warehouse. So I think the two could have or contribute to a nice user journey and blend naturally.
Okay, thank you. Now I will take the second question for George, because the first one was shortly responded, that it was about if you envision having parser for all type of languages for SDTH.
Well, I wasn't, yeah, so the question was about using abstract syntax trees of languages. And I think sort of can answer on two levels. Yes, in order to get from a language to get to SDTH, you're probably going to have to go through an abstract syntax tree. But that's not all you have to do, because in the original language, the program steps are all sequential. And that means that you have to start at the beginning of the program and go through each of the program steps in order to identify the variable instances, the data frame instances, the file instances, and when new states, new instances are created. Now, you could do that by getting the abstract syntax tree for each separate language, and then you need to go through each separate language. Our recommendation, however, is that you use our other language product, Structured Data Transformation Language, for which we already have prototypes of 5 what we call parsers that go from an original language into SDTL. SDTL is structured, meaning it's expressed in JSON or XML or something like that, so you don't need to get an abstract syntax tree. And we think that we have a sort of earlier generation prototype that can create SDTH, or a predecessor of an antecedent of SDTH from SDTL. And so we think the strategic model is to go from the original language into SDTL, and then from SDTL into SDTH, and that reduces the number of program coding, amount of coding that you have to do.
Thank you, George. Arofan, I will ask your two questions. The first one was from Olaf. It was a bit long, but correct me if I'm wrong. Your question was basically what evolution also Arofan sees in the official statistics community. Was that?
I remember that.
Okay, good.
So, Olaf, I do remember talking about this in the past. I think there has been some progress made. What I see is a growing awareness of FAIR as a thing in the official statistics community more and more. I'm also seeing, and I think these are not unrelated evolutions, heightened interest in access to microdata, even in places like, Lord forbid, central banks, where the data is super confidential and microdata has not been a huge disseminated resource. And there are obviously issues around confidentiality and access, but so I actually am seeing the official statistics world waking up to some of the issues that have been omnipresent in the research world for a long time, and vice versa, where there's more awareness of some of the discipline and regularity that has always characterized official statistics production, and that when you really have to start using standards to share data, that becomes a real asset. So are we there yet? No, we're not moving as fast as we'd like. Will we be there in 5 years? Likely not. Are we making progress? Yes. And I think we had a meeting yesterday with SDMX and DDI and talking about some things, and that was the sort of meeting I think that could bear a lot of fruit if we pursue these things together. So I think that answers your question. Yeah.
Thank you. We have 2 minutes left, and I will ask 2 more minutes from the chair as a loan, so that we have 1 minute for each presenter to answer the second question. So, György, the question was about, from Marco, was about unit of measure as dimension or attribute. It's a quite common question. And what is, in your knowledge or in your idea about if this is only a matter for the SWG or also the TWG should be involved?
Yeah, I mean, in the work that we conducted in this task group, we ended up being quite agnostic on how units of measure should be modeled, and we felt that it should really be the other aspects of the cube design that should decide whether some of the components that we consider as part of the unit of measure or direct determinants of the unit of measure, whether they should be dimensions or attributes. But as you rightly said, in most of the case, the full, let's say, long form of the unit of measure, which contains the unit multiplier and the unit core unit and some other elements, would be an attribute in a data model. And with a little bit of redundancy, you could always make it an attribute. But the point is really to identify all the components that would be dimensions or attributes that you would need to clearly pin down the unit of measure and actually express the unit of measure. So not necessarily the anchor points of the unit of measures like the measure or sometimes the country in the case of currencies, but really the direct determinants or direct components of the unit of measure. And yes, I don't see the TWG angle.
Thanks, György. George, do you want to elaborate on the question about versioning?
Sure. So, yeah. So, an instance is a version in the strictest form. That, you know, I mean, sometimes versions have other things, but you can think of a very strict form of versioning, and that's what gives you an instance. And in SDTH, we have instances of files and instances of data frames. And the way it works is that if something changes at the lowest level, namely the variable, or a value within a variable, then the variable instance changes. And since data frames consist of variable instances, that means that the data frame changes also. So SDTH is really about versioning everything.
Thank you, George. Arofan, second question was for Chris. Advantages of the variable cascading in CDI-DDI versus the typical GSIM representation?
DDI-CDI is a more specific and formal, Chris, and it's a logical and implementation model where GSIM is not. And but I would comment that it's also there's more concept relations in CDI. That's, I think, GSIM could be seen as a basis to which we added some improvements. And I use that word advisedly. And I think the concept richness of it is one of them. That becomes incredibly useful in processing scenarios. But as you implement more, I think that becomes more visible. The differences aren't huge, but they're there, and it might be worth comparing them, honestly.
Thank you. And our last question is from György to Barbara. And it's about explaining or elaborating about property versus constraint distinction.
Yeah, so I would like to follow up what Arofan said, and actually I would like, as next steps, also to compare the four presentations to IADOPT, how these are helpful together. And actually, IADOPT is placed at the middle, so the represented variable. And the IADOPT concept is the conceptual one. And when I talk, when we come to the constraints, I think the constraints are helped to constrain the entities, but not the property. The property needs to be very precise, and if you need, so you cannot constrain a property. For us, only entities are constrainable.
Okay, thank you very much. I want to thank all the presenters for being so tight. Having a day chair, a British, is quite important to be accurate in the time. So thanks a lot for the questions as well. Yeah.